All right, continuing with the notes, we were in the middle of this problem, and is pi over 3 in the range of inverse sine? And the range of inverse sine is negative pi over 2 to positive pi over 2. So in fact, it is in the range. Therefore, sine inverse and sine undo each other, and we just get pi over 3. Or you could check and say sine of pi over 3 is what? So sine of pi over 3 is the square root of 3 over 2. And then you can go inverse sine. So sine of what angle gives us square root of 3 over 2, and make sure we're in the restricted domain. And in fact, it is pi over 3. All right, so let's move on to this one. So I have sine inverse of sine, but is it inside my restricted domain? So I'm checking to see if 2 pi over 3 is in the range of sine inverse. So sine inverse has a restricted domain between negative pi over 2 and positive pi over 2. So 2 pi over 3 is outside of the range of sine inverse. So I'm not going to be able to do cancellation. So since this is not in the range of sine inverse, we cannot use the cancellation property. All right, so we'll find sine inverse of square root of 3 over 2, which in fact we just did, so we know it's pi over 3. So now, I'm sorry, I jumped ahead. Sine of 2 pi over 3, that's what we need to do. So 2 pi over 3 is here, so the sine is the square root of 3 over 2. So now I'm looking for sine inverse of square root of 3 over 2, and that was what I was just saying. We already did that, so we know it's pi over 3. So notice that the cancellation property didn't give us the correct value here because that was not in the range of sine inverse. All right, moving on to the next page. We've just got a bunch of these to work through. So have the unit circle in your mind or in front of you. Now, cosine has a restricted domain, but remember the restricted domain for cosine is different. So let's switch back and make sure that we know what we're talking about here. The restricted domain for cosine goes between 0 and pi. So I'm going to color code that on my unit circle here. So in green here, I'm going to note that this is my restricted domain for cosine. Okay, so if I'm trying to find out what angle gives me a cosine of square root of 3 over 2, but I'm looking in this region, and cosine's the x-coordinate, so where do I get the square root of 3 over 2? I get it right there. So that angle is going to be pi over 6. All right, now I'm going to move on and say, what angle gives me a cosine of negative 1/2? And again, I'm staying in this domain. So cosine is negative 1/2 right there. So that angle is going to be 2 pi over 3. And now I want to look for cosine inverse of 0. So what angle gives me a cosine equal to 0? So cosine's the x-coordinate, so that happens here. So that angle is pi over 2. Keep going. So can I use the cancellation property? Because cosine inverse of cosine, they undo each other as long as I'm inside the restricted domain. So 2 pi over 3, is that in the range of cosine inverse? So that would be here in this region. So 2 pi over 3 is in fact in that restricted domain / range. So I can use the cancellation property. So cosine inverse cosine cancel each other, and I get 2 pi over 3, which was the value inside there. I'll do one more before I pause. So cosine inverse cosine is 5 pi over 3 inside the restricted domain, and 5 pi over 3 is over here, and it's not. My region for cosine is up here, so I cannot use the cancellation property. So I've got to think cosine of 5 pi